That's good. So that is the recall. What is recall? Whatever we already done, whatever you know from the basic thing. So that is the recall basic thing. Okay. What is arithmetic? Arithmetic is nothing as such. You can see it is the elementary branch of mathematics that especially deals with the study of numbers, properties of traditional operation like addition, subtraction, multiplication, division. Much, we have, you can say percentage also, you can understand average, mean, median, mode also, but that is the more generally we are going to discuss about the whatever the subtopic we are going to discuss. Is this clear?
Yes, sir.
Okay, so that is enough for this particular class. Now, what are the significant figures? Why it is recalled? Because this is the last subtopic, or you can say a thing what we done in the previous class. So I left you guys at parallax method because I know this thing that we going to recover or that we're going to revise in this particular class also. So, or we are running out of time in the previous class, physics class I'm talking about. Okay, so what is a significant figure? As in mathematics, we encounter questions where the solution comes out as 7.73. So we have a practice of rounding off the figures. So basically, what is the meaning of rounding off? A significant figure are the just numbers, whatever the solution you get. For example, if you are saying velocity, which is displacement upon time, because on the behalf of physics I can tell you, and distance is, you can say, 3.47 meter. Okay, and their time is 7.456 10.456 seconds. So automatically the meter second. So whatever the answer of yours, velocity going to be, it is going to be by the meaning of significant figure, the total number, or if I am going to write this time, if I am going to write here my time t is equal to, you can say, okay sir, good. Time t equals to 1 into 0.45 into 10 to the power. How much it is going to be? Minus 3 or 6? Minus 3 and minus 4, right? Minus 4. Yeah, because these are 3 and that is. So this minus 3 represents you, there are 4 significant figures. The power, or sometimes you also write it down this. This one is going to be, wait, 1.0456. Now it is correct. Okay. So here the time duration we have for in general total 5 significant figures. And what is this? This represent you the order, like up to which order you are going after a decimal. So the total numbers in any particular unit, in any particular numerical value of any particular physical quantity, up to which number we are going to count, that particular thing is known as significant figure. Obviously, if I'm going to round off, so round off is works on this principle. Suppose this is 2357. Okay, so that is going to be rounding off 2.36. Why so? Because this integer, the third integer, is going to be more than 5, or if it is going to be lesser than 5, so it is going to remain same. Okay, if it is 2.34, so then my rounding off going to be 2.35, the remaining same. Is this clear, everyone? If, okay, I repeat this thing. If it is, everyone means everyone, if it is more than 5, okay, so then it is going to be this one is your, yeah, I'll put it into the box also. Then this is one you're rounding off, and let me remove this. And if this particular decimal is going to be 2.352, so then it is going to be rounding off 2.35. Same thing. Why so? Because when the third number, okay, when this particular corresponding third number is going to be more than 5, it is more than 5, your third number, n, which is third number, in general, if we are going to round it off till 2 significant figure, okay, I mean after decimal 2. So that is if n, which is a third number, going to be more than 5. So this particular condition is known as your rounding off. Is this clear to each and everyone? Tell me, is this clear, beta, everyone? Because rounding off is simplest thing. Clear, Mukeshwaram or Bhuvana also, or Ashwita? Just turn on your cameras, everyone. Okay. So now, as you know this thing, so let's read out about it. We have a practice of rounding off the figures. Here we may count. Here we may get confused. That can 7.73 can be written as 7.7 or 7.730 or 7.0 also. So let's take another example. If you put 0 after the decimal, so it is not going to work it out. But if you put 0 just after this particular simple number, then it is going to be clear. Another example, suppose your friend's salary got increment of 55,000. Now he tells his salary has 55,000. However, close the exact amount is. Okay. This example is not accurate. Now it is going to be accurate. Suppose the increment is going to be 55675. You can say 670. So then what are you going to say? You can use this particular terminology and these kind of rounding off in so many general ways. For example, if you buy a phone or something, obviously that phone or something is not under this particular range. They always give you this particular range, 899, right? 1099. So till rounding off, you saying that is 11k. 11k stands for beta 11,000. Is this clear, everyone? So that is the meaning of rounding off. Even in general, if you buy a shirt of yours, suppose that is some offer is going on and that shirt of 1500 is going to be 50% off. Okay, 50% off. So obviously then you're going to be 750. So then what you are going to say? It is almost 800. Right? That is the meaning. In general sense, we are rounding off 50, 10, 30. But when we are talking about precise data, then we need to take care of a lot of things. And what are the lot of things? What are these things? Basically, these things are known as significant figures. Significant figure is just a number up to which particular range, up to which particular order, because that is known as your order, up to which particular order your answer is needed to be precise or accurate. This is the significant number. First of all, there are n number of rules of significant figures, what we are going to cover in this lecture, and there is a rounding off process also. So rounding off is just instead of exact amount, instead of exact data, you just rounding off up to the appropriate amount of range. That is the rounding off. Is this clear to each and everyone? Clear na? Shrita, are you there? Better just turn on your camera. Okay, I don't need to do that. You by yourself need to. Is this clear, everyone, right? So what is rounding off? What is this? Okay, so that is the okay. So what are significant figures? Which means he told the rounding off amount to you. The above example, I mean that is related to the previous slide. The above examples were to explain the significance of the figures or digits. So what is the definition of significant figure? Significant figure, that is the exact definition, is the measured value of a physical quantity which tells the number of digits. Sir, I couldn't understand. Which one, beta? Rounding off or this significant figure? The significant figure definition is here. I am going to explain again. In general, what is a significant figure? Significant figure is the measured value of a physical quantity. Okay, which tells the number of digits in which we have a surety. Means whatever the amount of precision surety you have for any particular value, that is going to be the significant figure of yours. For example, I'm giving you an example related to you. Shrita or Ashrita, what your name is, right? Suppose Ashrita buy a nail paint. Buy a nail paint. Okay, nail paint of you can say of price of rupees 785. You can see 7778. So that is the exact price. Is this clear? So that is the exact price. Exact price means up to 3 order, up to 3 range. These are 3 significant figure. I am going to write significant figure as a SF, S dot F. In this particular class, S dot F means significant figure. Keep it in your mind. Significant figure. Wherever I am going to write, I am going to write this S dot F. So that is the exact thing, right? So suppose Ashrita buy a nail paint of rupees this. Now whenever you are going to say or whenever you are going to tell to your friend, so you are going to rounding off. So round off price of this, round of price to your parents, because round of price of nail paint. To your parents, you are going to say, mommy or daddy, but obviously to mom, it is just very cheap and it is almost 750. Because if you tell the actual price to your parents, they scold you maximum number of times, right? Because they are not used to of this much. Uh, you can say spend money on these kind of products. Specifically, boys whenever they buy shoes, na, like 4,000, 5,000, so they just cut off 50%. Because if our parents going to know the actual price of shoe, like the branded shoes I'm talking about, so they throw us out. Even mine too. Okay, so you don't need to shy about it. Even I'm earning, so still, if I'm going to tell the actual price of any particular thing I'm buying myself, so they scold me till now. So Shrita going to tell her mom like that is the price of a, and this is also the price whenever it is in you can say offer. Actual price is going to be 1,000 and it is in the offer, so I bought it. But the actual price is 778, or it can be 798, or any particular thing, any particular number. Is this clear? What is the meaning of round off? Clear? And it can be round off to 1,000 also. If you some particular, don't feel bad in it. Some people have brag it off. Brag it off means like a show off kind of thing. Like this phone of mine is very costly. So they buy a phone approx 25,000, 30,000, and they just tell it is 40,000, 50,000. Okay. So this is going to be happen also. If you sharing the price to your friend or somewhere, so then you are going to say it's so cheap, but it's only 11. You can say 1,000 rupees, because for your friend to show off 1,000 is cheap, but to your parents it is going to be in reverse. 1,000 is not so cheap, and it is not a cheap thing. Okay, so that is the meaning of round off. I think now it is clear in each particular everyone. Clear? Good. Okay, so significant figure, the actual number, the actual value up to which particular range we are going to discuss for our physical quantity for any particular thing, and rounding off like in a shorter form, or you can say lesser time or maximum number of, we are going to discuss the rounding off in a lower range. More generally, we lower down the price, lower down the values. Sometimes we increases also, and that is this one. This one is the rule. If you need to find the particular amount up to third significant figure. So these are 3 significant figures. So for 3 significant figure value, physical quantity, if the n, or you can say this particular value, 4th significant figure is more than 5, so it is going to be 2.36. If it is less than 5, so it is going to be the remain same. Okay. Instead of third. fourth value, because here it is fourth significant figure. Clear now? So that is the you can say kind of method. What do you understand by significant figures? So let's recall this thing once again. Let's say you have a road and its length is measured to 25.3 centimeter. Here the digit after the decimal point is called the doubtful digit. It is because the measurement can be 25.2 obviously, 25.28 obviously, 25.35345 accurately, centimeter. I mean, which particular instrument you are going to use. According to that, the actual, accurate or precise value you are going to get. For example, for centimeter only. So, from the help of centimeter scale, you are going to get 25.2 centimeter. This one, it is going to be with the help of vernier caliper. Okay, 25.2 centimeter with the help of centimeter scale. Centimeter scale, and that is 25.28, because also it is going in a more range, so it is going to be vernier caliper. And the third one, which is going to be more significant figure, more precise value, that is screw gauge. What are the things I am writing here? These are the instruments which gives you precise value. I mean the precision or accuracy increases in this. Okay, one more thing. In simple physics, in this terminology, this is upward increasing, this is downward decreasing. So accuracy increasing in this order. Is this clear? Means your centimeter scale is not going to give you more accurate value or more accurate length as compared to the vernier caliper. In the same sense, your screw gauge is going to give you more accurate value of the length. Is this clear, everyone? Clear na? So this is up or increasing. These are the general terminologies. Time to time I am going to tell you. This one is down or decreases. Okay. So this is centimeter. We are not confined about the values to be preferred. While the digits in the number 25 are accurate, because we have a confidence upon these digits. So 25 is the you can say confident one. Like yes, exactly 25 centimeter, but 25.2, 25.28, 25.345. Which one is the? So adding all the accurate digits plus first doubtful digit is your significant figure or significant digits. Okay. So now here, as you can see, here we have three significant figures. Here we have four significant figures. And here we have five significant figures. So more the significant figure, more the accurate value you get. As simple as that. And what is a significant figure? What is a significant digit? Adding all the accurate digits plus first doubtful digit. Got it? Is this clear? Like 25 is the accurate one, but which particular instrument you are going to use, that is going to be give you the most accurate value of a physical quantity, more so ever, more significant. Clear? Okay, should I move ahead, right? Clear na everyone? Just type everyone yes sir if I am asking to you. Instead of this Pradyuman Dubey sir role. Good. Okay. So that is following the common rules for counting. That is very important, because based on that you get, if you are lucky enough, specifically in this JE, so you get the you get one particular question from this if you are lucky enough. Why I am saying if you are lucky enough? Because that is very easy as compared to the whole 11th class. In 11th class we are going to discuss most important, even most difficult numerical problem, as well as the hardest concept. What you going to understand? Even you sometimes are not going to digest whatever I am going to say. Okay, so just believe me sometime. But I try my best to give you the full clearance, full concept clear till the last. Okay. So rule number 1, all known zeros are significant figure. For example, we have number 7.7744. So we have 4 significant figures. Clear? Is this clear now? This rule number 1. Very simple. All the known zeros are significant figures. Nothing as such. It has 4 significant figures. Clear it out. Rule number 2. All zeros occurring between 2 known zeros. Why we are saying this? For example, you are automatically going to understand. See, 100 is 100, but if I am writing this, that is 1 only. So these 2 zeros are not going to work it out. But if I am writing this, so that is going to be work it out. So that is why 2 zeros in between 2 digits going to be as a significant figure, because that is have some value. Instead of, if I am changing this, wait a minute. So now it becomes 1905. I mean 1905. So that is going to give you the value. But the moment I write this, your digit is going to be changed. So that is 1900 or that is 19,005. Okay. So just adding one more zero. Okay. The same example I need to take. Just adding one more zero, the whole number is going to be changed. The quality, not quality, the quantity is going to be changed. So that is why the 2 zeros, this one is very important. The 2 zeros between the 2 non-zero digits are going to be counted as significant figure. For example, 2007 or 2008 is have a 4 significant figure or digits, and 1.083 and 079 has 6 significant digits or significant figures. Is this clear with everyone? Very simple, very easy, very basic, right? Clear na? Good. The next thing is third rule. Ending zeros, the ending zero will be significant figure if and only if it is after the decimal. For example, this you cannot count it down in the significant figure, 3400. But if it is, wait, for an example, the ending zero is after the decimal. Now, according to the rule 2, if the zeros are, this one is going to be 4, but 3.4000, it have 2. Clear? Because after the decimal, it is not going to work it out. As simple as that. But if you write this thing, so 340 is 3 and 3400 is 3400, and this 34,500. So this have 3, this have 4, and this have 5. SF, SF, SF. But it's have only 2 SF significant figure. That is the rule number 3. Why it is? Because this particular, the amount or the number of this particular quantity is different, and for this, and just adding 1 0, it is going to change the whole quantity, whole amount. So that is why we count this in significant figures. Is this clear, everyone? Is this clear now, everyone? That is very easy, very basic. Okay. One more thing, why it is counted as a significant figure, not this, because for this you can write 3.4, 1, 2, 3, 4 into, okay, 3, 4, 5 into 10 to the power plus 4. But you cannot going to write this, you can say this as a 3.4 into 10 to the power, how much? 4. Why so? Because it is already after a decimal. So this is wrong practice, or this is wrong, but this one is right. So whenever you are able to convert into the positive power or even into the negative power of this particular order, then you write this particular thing as a significant figure. If you are not able to do that, You are not going to write it down. A simple basic rule, zeros after, as a note you can write it down. Zeros. See, this particular zero can make you a hero or zero itself. Zeros after the decimal is not considered as a significant figure. Okay, keep this in your mind. Clear now, everyone? Clear, beta? Good. Okay. So rule number 4. This is rule number 3, right? Okay. So this one is your rule number 4, and what is this? Rule number 4, or rule for initial zeros in a number less than 1. If your number is less than 1, focus here. All zeros to the right of the decimal point and the left of non-zeros digit are significant. What is the meaning? This particular have 0.0000, only 2 significant figures. Why we cannot count this? Because these are not going to be matter. Okay. So here we can see 0 at the initial before the decimal point, which is not significant figure, and 3 non-ending zeros has 2 significant digits, or this. Let's say a number, this one. Obviously, this is going to be 3 again, because this particular 0 can change the number even after the decimal. So the rule after this particular decimal is going to be the same. The 0 in between 2 non-zero values is going to be considered as a significant digit or a figure, but the 0 initial or after the decimal, it is not considered. As simple as that. Okay. Here the initial 0 is significant. For example, this have 4, but this have 3 significant figures. Why it is have 4? Because it is not after the decimal, but it is having after the decimal. So this one is 3 significant figure or a digit. This one have 4 significant figure, but this one have 2 significant figure. Is this clear to each and everyone? See, I can understand your right point right now. Why, sir, this focus on this significant figure? What is the use? Why we are going to learn this? See, right now, this seems very basic, very easy, even very boring for me also. Like, but this is going to be very helpful. This particular units, dimension, measurement, specifically dimension, if you are not knowing the answer in guessing out. Okay, specifically not significant figure, but dimensional analysis. Like, what is the dimensional analysis? MLT form, right? And more accurately, if someone asks you, I mean, if in any particular course numerical problem, there is a, they ask, write the particular amount of, you can say, momentum. Momentum is P equals to mv, simple, in 4 significant figures, right? And you are not aware about how to count significant figure, and the rest 3 options are just 2 significant figures. Clear? So automatically, without even calculating this momentum, the quantity, the option have 4 significant figure, you can write it down, because you do not need to calculate it, because the examiner wants it, but not in a direct way. Because what you think, like, they ask direct question on this, just give me, just count the numbers. No, never. Right now, they form the question in a very large language, like if a person P is moving with some initial velocity, this, and then after some time it is going to move with some final velocity, that, having mass, that. So find the force up to 4 significant figures. So your mind is going to find the force even without thinking, even without seeing the option. And the option somewhere going to be, suppose, like whatever I'm saying right now, if I form the question, so suppose option A, B, C and D, and your forces need to be four significant figure, right? So suppose one is 0.0023, another one is 0.2400, another one is 0.2060, and another one is 0.7008. So now tell me, beta, which one is correct? You tell me. Forget about everything. Now this is right now I'm forming the question. Find force up to four significant figures. Newton, 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 Newton. Tell me which option is the correct one. Simple basic question. Direct even. Everyone. Tell me which is the correct. Tell me, beta, everyone, please write it down. You yourself write it down after seeing that. And whenever you write something, just try. Ready to explain also. I can ask the explanation also. Okay, that is very basic. But if I'm changing any particular value, so automatically you are going to confuse. Okay, right now you have that knowledge because after the decimal, see, right now even 2 or 3 people are confused. A or D. Beta Pranav, see, the zeros initial zeros after the decimal or even without the decimal, that is what? It is 76 only, but that is 76,000. Okay, so the zeros after the non-zeros digit is counting as a significant figure, but if I put a decimal here also or a point, so that is not counted as a significant figure. Okay, so this have two significant figures, this one have two also, now this one have three. I change the method and this one have four. Is this clear? So even I am writing the question direct, see, then you are confused. Now you think in this way, like you completed first book, just first book, not the full 11th syllabus. And I am going to frame a question very lengthy, like a person B is moving with this velocity and so and so. Okay, and you hit the ball, what is the force, and so just because that is how as an examiner or as a teacher we frame the question. Like we confuse you first and then ask very simple basic. The main answer is to write the four significant figures. Even if you have the knowledge of four significant figures, without calculating, without the need of calculation of this force and everything, you just see in an option, right? Okay, this one is having the correct four significant figures. So the option D is correct. Okay, that is the way to give the answer. Read any particular physics, specifically I am saying, read any physics, any particular type of numerical question in physics twice, then write it down what the examiner, the questioner wants to know from you guys, from as a student perspective in an answer, and then find the shortest way. And obviously it is going to be happen within a second if you are doing practice and practice and practice and understanding the things. I'm saying, I'm repeating this again and again, learning in physics without clearing the concept, it is not going to work it out. You try, you can think that right now you can maybe have that idea like I can learn all the formulas and then I am going to apply. Believe me, don't do this. If we are doing so, so very small data I am going to give you. See, in 11th class, we have 15 chapters or 14 right now, right? In 11th class, we have how much? 14 chapters. If I pick only 10, so 14 into 10, we have 140 formulas. And each particular formula is related to each other. So you are going to confuse yourself lots of if you try to learn formula and then try to solve any particular numerical value. Clear na? Because you are not able to do that. Even I am not. So I am not learn any particular formula. I just understand and because of this particular teaching, I have that knowledge. Okay, but if you ask me any particular formula from any particular chapter right now at that moment, I am not going to tell you because I don't know. Even I don't remember. Clear? So you don't need to remember anything. You just need to understand, clear the concept, correlate with your physical surrounding to your nearby things. Everything in physics specifically is your nearby. Okay, so moving ahead. Following are the common rules for significant figures in a given expression. Rule number 5. Already we did this. All zeros on the right of the last non-zero digit is in the decimal part are significant figure. For example, this has 3 significant, but or you can say this one also has 3 significant figures. Okay, because that is 700. I can write, okay, why it is counted as 0.00705. The moment I write 5, it is going to be give me 3. So that is why zeros ending to the right after the decimal can give me significant. What is the meaning the moment I write here 5? 7.051234 into 10 to the power minus 5. So this is till minus 5 range. Okay. So that is why even if I am not writing this 5, just remove this 5. Now, is this clear? So that is why zeros after the decimal counted as a SF, significant figure. Clear? All zeros on the right or of non-zero digits are not significant figures. Here we have numbers like 420, 4300. The ending 0 is not after the decimal, so 0 is not significant and they have 2 significant end digits only. Wait, 42, 43. Okay, so the non-zeros counted as a significant figure. So this is have 2, this is have 2. Okay, so even if you write this 4300000, so they are counted as a 2 after the decimal word. There is some typo maybe. Okay, it is going to be after the decimal. Not is not going to be. Ending 0 is not after the decimal. Okay, so this one is going to remove because it is going to be counted as a. Just remove this not. Okay, because obviously it is going to change. It is going to change a lot. So rule number 7. Okay, we already discussed this rules. So rule number 7. Power of 10 is a insignificant. 3.4 10 to the power 8. Now the moment you write into the power form, so you have only this. Okay, 10 to the power 8 ending zeros, but the power of 10 is always insignificant and having only 2 significant digits. Is this clear, everyone? The moment we write into the power form, the non-zero, because that is the power, like 0. So these zeros are not going to counted as a this, and that is one your important rule also. Okay, so if this is going to be 4, but the moment you write this, now it is have 2 significant figures. It is a method to write it down. Suppose this is your velocity. Meter per second. Meter per second. Is this clear with everyone? So it is have 2, it is have 4. Clear everyone? Okay. So that is an exceptional rule, and that is important one also. Exceptional means something different from the others. Basic operation in mathematics, that is, you know, the 4 basic operations of arithmetic till the previous slide. This is clear now. These are 7 rules. So if you have a still doubt, go into the previous, I mean after this particular video, yeah, after this class, watch this again. If you still have a doubt, so ask me in the next class. Now basic operation in arithmetic, as we know, the 4 basic operation in arithmetic: addition, add, subtraction, you can say subtract down, multiplication, division are discussed is below. Addition, subtraction, multiplication, division. Okay, so this one is your first question. Try that. The sum of two numbers is going to be 100 and their difference is 60. Find the numbers. Very easy. Mathematics question. Even I don't want to give hint here. Do that, beta. You need to find the number. This is class. Okay, one more thing. Wherever we going to discuss questions in this, beta, so more so ever we going to discuss the not that much complex, moderate question in general. Why so? Because this is the combination of batch of NEET, CBSE, JE, or 80 and 20. Okay, what I am saying. Yeah. So the number of numeric the type of numerical is not going to be that hard. But obviously, after some time, if we, I mean, if I personally see a progress in you guys, so I can do that. Everyone, how to solve this? Just give me this. Rounding off Sydney. Okay. The answer is 80 or what, beta? 20. And the method is easy. X plus y is 100. X minus y is 60. Add both the thing. Sorry. Add both the scenario. So x is going to be 80. If x is 80, so then y is going to be 20. Is this clear? Is this clear to each and everyone? Na? Bhuvana, Shrita, Pradhyuman also give the answer. I mean already give the answer. From very basic roots, let two numbers x and y. X plus y is 100. Okay, x minus y is, you can say, yes beta, 80-20 is 60. Equation 1, equation 2, add both the equation. 2x equals to 160. So x equals to 80. So x equals to 80, put any particular equation. So automatically y equals to 20. Okay. And I don't know why they do with this large form. I mean, they subtract or they just use the substitution method. I mean, they substitute the value of x, then finding y first, and then put it in the value. So any particular method. Okay, one more important. As you guys are preparing for JEE. Okay, 2-3 things I'm going to give you here. Very basic in the initial days of your preparation. See, that is the very important thing, or you can say trick to solve any numerical. General trick to solve numericals in physics. Okay, and that is going to be help out throughout your course. First trick, read question 2 times at least. Read question 2 times. That is going to give you more clarity. Why I'm saying read question 2 times? Because the moment you read twice or second time, you get more clarity what is the given things and what the examiner or the questioner asks to you, right? So that is the very basic thing. Read question 2 times. Second thing, write down the given things. Given things. And the third very basic step, find shortest method to do that. Find shortest method. Simple. Because obviously, to solve numerical for any entrance exam, to solve numerical here for any entrance exam. See, in any entrance exam, the main task of yours is to solve objective or to get the right answer. Clear na, everyone? So obviously the main motto of your, and that is how you need to practice specifically for any ent exam. Obviously you need to know how to write in a subjective paper, how to write the lengthy thing, but specifically to solve any numerical for any entrance exam, not for physics thing, but it is general for maths, for chemistry, for physics, for chemistry, for bio. Clear na? Read question 2 times. At least for physics you need to use this. Write down the given things and find the shortest method. Like you can use this one also, but why you need to use this one when we have this? Isn't it? The answer is going to be same. 80-20. Now it's your choice which particular which particular path you're going to choose. This one, 3 lines, or this one, so many lines. Clear? Is this clear na? So that is the method. General trick. I'm not saying or stating something like you don't know. The main thing is you know, or we all know, but we don't apply this. Simple. We know so many things, but I don't know why whenever any particular exam have physics part or something like this, so maximum number of time we do physics in the last, and in the last obviously it depends how the other subjects are. If you are really good in other subjects, so your 2 by 3rd or 50 or 70% paper is going to be good, and then you opt for physics, so obviously then it is going to be the good ending of the exam or ending of any entrance exam. But if it is not the same scenario and the other two subjects are, you can say, more complex as compared to the moderate, or they are hard or they are difficult ones, then your whole paper is going to be done in wrong way. Then means I am done with the paper. I am not able to focus more. Okay. So that is in general thing. So for any particular numerical thing, you try this. That is going to help you out. Okay. This one is the same thing. If the sum of two numbers x and a plus 5 is this, find the value of x. Okay, do that quickly. Okay, according to question, the sum of x and a, where a is something. So give me the number. Very easy, this one also. Sir, should I call you? Why, sir? Wait a minute, I am just going to give the Siddesh sir, yes, go ahead. Okay, solve this beta, and then I am going to be here again. Beta, number is going to be some numeric value. You need to find the value of if two numbers x and a plus 5 is 39. One thing is missing is here. Wait. 34 minus a, and then what? Okay, x. Oh my goodness. Yeah, 34 minus a. Exactly. Uh, there is some mistake in this, because whatever the solution that SME of R create, I don't think so. I mean, he or she wants to write he, not she. A is x plus 5. And then, okay, I'm changing the question here. The sum of two numbers, x and a, is 39, where just give me a minute, where a equals to x plus 5, then find, even this one is easy, or so easy also, find the value of x. Okay, okay, do that. Beta, how x can be 14 then? Yeah, it is 17. Okay, so these are silly typos. Okay, okay, do one thing, let's take a break, because then we are going to do in a continuous manner. Like, let's take a 5-minute break, not more than that. I need to drink water, because I need to speak a lot after that. Okay, so just a simple 5-minute break. Huh. Rounding off. After this particular thing, we are going to talk about rounding up, and the correct answer is yes, 17. Okay, read this also. Hello, hello, hello. Am I audible? Hello. Okay. So now, see why I'm laughing myself, because this is going to be a little bit more boring, because whatever we already know, whatever the maximum thing you guys know, that is written down in the language, or you can say pen and paper. So I'm going to read this and describe it quickly, and we are going to do the main thing. Main thing is numerical value problem or questions. Is this clear, everyone? Clear na? So just a kind of revision. If you still need any assistant or something, what you don't understand here in the written format, so you can ask me out. Okay. So rules while applying arithmetic operation on two significant figures. Um, Two values when they go arithmetic operation. Final values obtained will always have more significant figure. Simple thing. If 7.05 is added down with this 2.30. Okay, so we just add it down. So the final version is 353,729. So that is going to be 9.353. The four significant figure you going to need it, write it down. 353. That is the written thing till here. Okay. So for example, say in order to determine the current in a circuit, the resistance and the voltage as given in 6.7 ohm, 6.77 ohm, and this is your voltage, this is your resistance, this is your voltage. The current obtained will be in this much order. Obviously, the maximum order is 12.559, which is 5 only. The value of current has a lot more significant figure as compared to the values of voltage and resistance. But it is known that when some operation is done on two quantity containing the errors, the final result will sure have more errors than the given quantities. Therefore, certain rules are made to understand the significant figures when they undergo any arithmetic operation. What is the meaning of this error thing? Obviously, it can be the last two things, the last two digit can be this also 7.0634373. So these are after the, I mean, as we can, this is the fixed, and you can say without doubtful digit, and these are the doubtful digits. So whatever the doubtful digits, these are known as error, or simple, because error word is appear here first time. So error is nothing but a true value. Okay, that is your true value minus measured value. That is your error. As simple as that. Okay, that is the simplest definition of your error. Clear, everyone? Is this clear? Are you there, Pradyuman or Bhuvana? V Bhuvana. Okay, beta. So that is the common sense, and that is the main thing for this page. If you add it down two significant figures, the more significant figure have, you can say, uncertainty. In more uncertainty means it can be the possibilities that has more, you can say, more amount of errors, and error is what? True value minus measured value. So arithmetic operation on significant figure. For example, take the previous example when R resistance is 6.77 ohm and V is this much. So I equals to V by R. V by R is this. So that is your ampere. According to the rule, I should have three significant figures. That is I equals to 1.85, because that is your three significant figure. Okay. So if it is, I mean, if they wants to give you in three significant figures, so that particular thing you needed to write it down. If they wants to write this particular thing in the more significant figure, so you need to write it down this. Why we write it down only three in the pattern of three? Because these are, I mean, this 12.559 are the doubtful digits. So obviously, if you have a doubt in this, so you need to write down in a less doubtful manner. Okay. Is this clear, everyone? Sometimes they ask you, sometimes they tell you. So if they don't, so write in a short, you can say, lesser significant figure manner. Simple as that. While dividing or multiplying, the final value obtained must have the same amount of significant figures as the amount in input values. The input values with less significant figure. Again, because we know after a decimal, after this particular point, the doubtful digits are there, and we need to write the less significant significant figures, less significant digits values. As simple as that, even in multiplication or division. Okay. So what we can write down here as a note in general. Note in arithmetic operations. In arithmetic in arithmetic operations, for PQ. For PQ stands for physical quantities. We are going to write. We are going to write the final answer. The final answer with less significant figure if nothing is mentioned. Clear? Nothing is mentioned about the number of significant figures. Clear? Is this? Okay. Means even if you are doing multiplication, division, subtraction, addition in all the types, because after the point the significant digits and the significant digits are known as a doubtful point, or you can say doubtful digits. So you need to write in a less number of significant figure if nothing is mentioned about the number. If specifically they want to write you in a more precise way, like write in the this particular physical quantity in 5 significant figure, in 4 significant figures, so you need to write it down in the same way. Okay, while adding or subtracting, the final result obtained should have as why okay in addition, okay, that is for wait, instead of in arithmetic operations, for multiplication or division, and in addition, this is the point. Okay, so while adding or subtracting, while adding or subtracting, the result obtained should have as many as significant figures are as present in the input value, with the least significant figures again the same thing. For example, take it what happened to me today. All you can write. I am confused myself. Okay, so this is the general thing. Okay, is this clear, everyone? The basic thing is, whenever you have more significant decimal, because before the decimal you can, without the decimal you can write it these things into the order. For example, if it is written in this way, the speed of light in general in actual is something 2.95643 or 4213. How many? 1 2 3 4 5 6 7 2. So rounding off this, 3 into 10 to the power 8. Why we are doing this? Because it is not point even here. It is in this way. Wait a minute. 295. Okay. 1 2 3 4 5 6 7. 1 2 3 4 5 6 7 8. Remove this then. So this is in this way. 2 point. Okay, 1 is going to be 2. Now if I am going to convert, so I can write 2.954621328 into 10 to the power 8, which is going to be converted into 3 into 10 to the power 8. That is speed of light, right? See, so whenever there is a large number, so we convert that particular large number into the power, and whenever we have a power, so we don't count it this 10 to the power. So we have this. So this is for large number. Obviously, if we have this thing, you can say this 4.55674. So initially we know this, we learn this, we read it, we know this. Like these, after the decimal, these are doubtful digits. So even if you are doing addition, subtraction, multiplication, division, the less number of doubtful digits are, the more accurate your value is. So in this way, in any particular arithmetic operation, we are going to write the less or least significant figures. Is this clear, everyone? According to this example, clear? Okay, because see, this is very easy to write it down even in this format, because sometimes you understand 2.9564213 into 10 to the power 8. So now you tell me which one is easy, this one or just rounding off 2 into 3 into 10 to the power 8. Obviously 3 into 10 to the power 8. And in general 3 into 10 to the power 8 we more write it down in this bookish language, in format or in everywhere. Okay, just turn on your cameras also, beta. Everyone other than Pranav, because Pranav only just have this. Okay. So for example, take inputs this one. If addition is done, these two inputs, the result 12.5424. However, the result should be considered as 12.54. Why so? Because only we have 4 significant figures. 1, 2, 3, 4. So this is the answer, accurate one. Clear? Good. Now important points to keep in mind, to remind, the change in the unit of a value will not change the significant digit. For example, 23 meter can be 2300 centimeter, 23 this much mm. So they all have 2 significant digits or 2 significant figures. Why so? Because you can write this again 23 into 10 to the power 2 centimeter in the same way, 23 into 10 to the power 4 mm, right? So the moment you change the unit, because 1 centimeter equals to 100, what I'm writing today, 1 meter equals to 100 centimeter, and in the same sense 1 meter equals to 1000. Am I writing the correct way? No, I'm writing incorrect. Okay, so these are the numbers. Is this clear, everyone? So that is why the moment you, even if you are changing the digit, still your this particular thing, this significant digit or significant figure is going to be. It is better to use, see, that is the notation. It is better to use scientific notation while denoting measurements. The notation should be a into 10 to the power b. This is going to be into the power a into 10 to the power b. So we have only to count this a. For example, take the above example, 23 meter, 2.3 into 10 to the power 1 meter, 2.3 into 10 to the power 3 centimeter, 2.3 into 10 to the power 5 centimeter. So obviously 2.3, 2.3, 2.3 all have 2 significant figures. Clear? If the exact digit is divided or multiplied, it will give the infinite significant digits. What is the meaning? Next example you can see. See, oh my goodness, directly relative error, relative or functional. Wait, this is something. These 2 slides are not going to be incorporated here. Okay, that is going to be in the next class. Rounding of digits. Okay. Wait. So what is the meaning of this? If the exact digit is divided or multiplied, example, suppose 2 or into 3, what it gives you 6, but you can write 6.000000. So that particular thing is recurrence or infinite significant figure. Is this clear? Is this clear, everyone? Shrita, Bhuvana, Mokeshwaram, Pradyuman Dubey or Pranav? Which one, beta? This one, last one. Exact digit means, okay. See, we can write this 3 divided by 3, or you can say 6, that is 1.2 0.5, right? And 0.5 into this. We can write it down. Is this clear? So 0.5 is 5 into 10 to the power minus 1. Simple. One significant figure. I can write this way in, I can write my 0.5 into this way also. So after decimal, the zeros is going to be non-terminating, or you can write n number of zeros. So these values are basically, or exact, this particular value known as infinite significant figure, if I'm writing this way, because I can put 1 here or some. So now 1, 2, 3, 4, 5, 6, 7. Okay, so that what is the meaning of this? 7 and this 8. 8 significant figures, and these have 7 doubtful integers or doubtful digits. But this only 0.00000. So that is the meaning of writing down this thing. Clear? Gohana, you are still looking confused. Means, see, you can write 2.5. After that, either you can write in this way, or you can write this way also. That is, everything is going to be remain same. So after the decimal, if you put so many number of zeros or anything, so they are not counting under the categorization of significant figures. These particular known as infinite significant figures. But it is going to be done only and only when 2 exact digit is going to be. Exact digit means this, like n can be integer, or you can say whole number. 4, 3, 2, 1. Clear? Okay. So skip this part because it is, we are going to discuss this in error. So what it is? Rounding off the digits. So rounding off implies simplifying a number by retaining its value but moving it closer to the next number. It is performed for whole number as well as decimal at various spots such as hundreds, tens, tenth, and so on. Means if you have any particular number, so moving more closer towards the decimal power or to the decimal. For example, the same thing I'm going to repeat. If you have a, you can say wire of a length, length of a wire of a length, length of a wire. Okay, so length of a wire is going to be L, 2.37685. It can be this. If you need to convert it, if you are going to round off this particular thing, into 2 only, into 2 significant figures. So as the third significant figure is more than 5, so beta L prime, which is after rounding off, the length L prime becomes 2.36 centimeter. Is this clear, beta? Is this clear, everyone? Okay, so that is the meaning. See, you can, because these are the doubtful digits. This one is undoubtful. So that is the meaning of rounding off. And I already give you the best example rounding off, to know the rounding off. What is the meaning of, actual meaning of rounding off? Okay, so these are some rules. Let's discuss this one also. A standard convention is followed while rounding off the digits. If I write it down, that is written on the paper. That's it, nothing more than that. If the digit is to be round off is less than 5 in the specified number, then the preceding means the previous digit. Again 9.546, this is your preceding, and 7, this is the exceeding. Okay, preceding, pre stands for previous, accessing, away, or you can say after. I personally understood this in this way. It's your choice, whatever the particular analogy you are going to take. See, this one is preceding. Let me check the spelling. Preceding. Preceding stands for previous. Okay. And this one is ASCEDAS. Okay. I mean away or after. That is how I understood. Or sir, is it 2.4? Which one, beta? Which one we are talking about? This one? Yeah, it can be L prime. See, I need to write this L prime into 3 significant figures. Okay. So for 3, it is going to be this. If I need to round off, or the answer is, or some examiner is round off up to 2. Up to, nice one, round off up to 2 significant figures. So beta, round off up to 2 significant figures, L double prime is going to be 2.4 centimeters. Is this clear what I am doing here? What that particular student asked? See, here we have 1, 2, 3, 4, 5, 6. Okay, here we have 6 significant figures. So in more amount, it is going to be undoubtful. See, this is for 3 significant figures, and this is for only 2 significant figures. So according to the question, according to the need, we're going to change it out. Clear? Okay, let's focus on this because time is running like the previous class, and I don't want to skip today this class assessment. Okay, so this is the preceding digit is left unmodified. As we know, if it is instead of 6, I can, if I put 2, so this is going to be 9.54. Example, 9.81 is round off to 9.8. Since the digit to be dropped is less than 5 and the preceding digit is left unchanged. If the digit to be rounded off, I mean up to which range you are going to round it off, that is the case. If the digit is rounded off is greater than 5 in the specified number, then the preceding digit is modified and raised by 1. Since the beginning, I am just raising the 1. For example, 2.36 is going to be 2.4. Okay, or this you can see that 2.376. Okay, if it is 6, so obviously it is, why don't you focus here? If it is 6, so it is going to be 7. 2.37. But if it is 4, so then it is going to be remain same. 2.6 na. Again, I am doing something wrong. Where are your focus beta? 2.38, because see, the third is more than 5, right? So the preceding digit is going to be 1 more. For example, this 9.88 is rounded off to 9.9. Since the digit to be dropped, means this particular digit is going to be dropped, is more than 5. So the preceding digit, this particular digit is going to be incremented by 1. Is this clear, everyone? Is this clear, beta? Good. Okay. Now we have some more rules. These are the most common things, or you can say most common rule. First one, second one, let's discuss third and fourth rule. Okay. If the digit is to be dropped out is equivalent to 5. I mean, if we want to drop out the digit which is equivalent to 5, and if followed by other non-zero digits, then the preceding digit of the specified number is raised by 1. For example, 7.555. So obviously it is 5, it is 5, so that is going to be 7.56 either or 7.8. So has to be rounded off, consider the tens digit, then it is rounded off 9.8. Since 7.55, it is more closer to the 80, or you can say 800. 755 is more closer to 800. If it is 745, so it is more closer to 700. So that is the analogy, that is the sense. If the digit to be dropped out equivalent to 5 or 5 is followed by the other 0 digit, for example 9850, so then we stick to this 9.8. Is this clear? Okay, so that is, then it is going to be 9.8 because other zeros are there. Rules to remove ambiguities in determining the number of SF. I mean, if you have some, you can say ambiguity, or if you have some doubt, so how to remove this? Some of the important rules to remove ambiguities in determining the number of significant figures. Very important thing, this, because here we have so many doubts. So the first thing, change in units means sometimes we see whenever we change the units, so changing units going to give you more significant figure. Simple example, 23 centimeter can be write it down 230 mm. So obviously you are thinking then this particular value B have more significant figure as compared to A, but it is wrong. So that is the first ambiguity, means that is the first confusion. Clear everyone? It is clear na beta? So that is the first scenario. So what other than this we are going to discuss like this. So change in units should not have an impact on the number of significant digits. For example, 5.900 mm, 590.0 centimeter and 5900 mm all have two significant figures. Okay, the first the first two numbers are four significant digits, and the last one has two. Means all the things I have this two significant figures. Okay, this is not correct. This is 2. All the things have 2 significant figures. Scientific notation can be used to report the measurement of numbers. Scientific notation is A into 10 to the power B. This is your scientific notation. Multiplication or division of exact numbers can have an infinite number of significant digits. We already know this. We already talk about it. Rules for rounding of the digits. Okay, so that is done also. I mean, that is general formula. For example, 9.750 has to be rounded off. Consider the tens digit, then it is going to be 9.8 since it is followed by other zeros. So the first non-significant digit is at 9 plus 1 position from the leftmost place. Clear? Is this clear, everyone? Good. Rounding off, rounding rules for whole number. So as a smaller place value for the specified whole number is chosen, use the next smaller place which is towards the right of the number that is being rounded off to. While rounding digits from tens place, a digit is ones place is looked for. For example, if we are looking at the tens place, so we need to look at the first place first. Look for the magnitude of the digit. If the smallest place is less than 5, then the digit is left untouched. Any number of digits, I mean the same thing is going to be repeated here. Read it out and nothing is new here. The same thing. Okay, if the preceding digit which is going to be rounded off is, the preceding digit is going to be remain same. If the order up to which you need to round off is less than 5 or 5 actually, and if it is more than 5, so it is going to be changed, incremented to the n plus 1 or plus 1. Clear? Is this clear, beta, everyone? Rounding off for the decimal number. determining the rounding of digits and evaluate the right hand side. If the digits on the right hand side are less than 5, they are considered to be equivalent to 0, or if they are equal or greater than or equal to the 5, then add to the plus 1. For example, again this thing 2.367. So if you need to write round off this thing into up to 3 significant figures, so that is going to be 2.37. Okay, but if it is 2.402, so obviously it is going to be then 2.4 only, or you can write 2.40. Simple. Clear? Even I am getting bored now. Okay, let's move out to the rounding up to the nearest tens. The same thing. I'm not going to repeat this. Several estimate techniques. Okay, wait. This one is done. This one is done. Do this. Okay, you can stick to this. Read this, because this is the same thing. Rounding off to the 100, rounding off to the nearest 10, rounding off to the 100, and rounding off to the 1000. If you're still feeling like you are not able to get it, so let me know. Do this quickly, and after these two questions we have test, and how you opt the test I am going to let you know. Just do this two questions quickly. There is one and there is another one, and then we are done with the theory part. Round these numbers to the 3 significant digits. Is everything okay with you, Bhuvana? Because you are doing so much activity in the class.
Yes, sir. I get the notebook over there, so I went to pick it up.
Okay, there is one again. Whenever you are sitting with any particular subject, not only mine, specifically with the physics, so from the beginning you just sit with a pen and paper, because maximum number of times I speak a lot, and you need to write these small things in your own language, whatever the preferred language you are, your own Kannada, Tamil, Marathi, anything, everything. Okay. 9.845. Round of these numbers to the 3 significant. Okay. 6.75. Why 6.75 beta? Up to 3. If it is going to be increased, so it is going to be 7.4, no? 6.74. See, one thing, even in equal, because after this it is not going to written down. So the solution for both the things in 9.845, it is okay. Your preceding number, or this you can say, this particular number is equal or greater than. Okay, so one thing I can up to the 5, so you can change it out. So it can be 9.85, because it is more closer to the higher order. Yes, so the answer is for A 9.85. Obviously, in the same analogy, for B 6.74. Okay. Here the explanation is not correct, because the number of to be rounded off is equivalent to 5. So in the first case, the preceding digits are even, therefore remain unfolded. Okay, one method is this one also. The preceding digit even or odd, therefore incremented by 1. Okay, what is the meaning? What that particular, if this is going to be even, so they change, I mean they not change. If it is odd, so they change. Sometimes this rule is also followed. So that is going to be 6.74, but according to the explanation, it can be this one. Okay, but you don't need to follow two rules, just follow this one. So write 585. Okay, find this one. What are the numbers? And on rounding off to the three significant figures. The same answer is going to be here as well. Okay. Okay. It's done. That is the same answer. Just solution. I need to personally check the amount of, I mean the level of question. Hmm. So as you can see, 4.845 again following the same rule. So 4.84 because of even thing, because 4 is even, okay, and 4.835 it can convert it to 4.84. Also the both the things 4.84. Yes. Okay. Okay. So how this is the summary. Wait. Yeah. What we done in this class: rules for arithmetic operation with significant figures, rounding of the uncertain digits, rules for determining the uncertainty in and in the rules for arithmetic calculation.